Hello, I'm Impact Weather Meteorologist Chris Bear with our countdown of the top 10 problems with most hurricane response plans. We're going to take a little bit longer with this video because we're going to detail the solutions to both problems 3, the failure to incorporate the speed of movement or potential changes in the speed of movement, and also problem number 2, which is a focus on the forecast arrival time of the wind field. Now, we've looked at many hurricane response plans over the years. In many cases, we'll see triggers for the action timeline such as this, 5 days out, 120 hours out, 72 hours out. The first thing I'll ask the customer is, what does out mean to them? And the response is, well, it could be the forecast of the arrival time of the center of the hurricane at the coast, but in most cases, that forecast is of the arrival time of the wind field at the client location. Well, that's all well and good as long as we have a perfect forecast, but unfortunately, forecasts aren't always perfect. Hurricanes do often change directions and arrive at your location even though they weren't initially forecast to hit you, as was the case with Ike back in 2008. The forecast here, 84 hours before the tropical storm force winds struck the upper Texas coast, was for no tropical storm force winds up here in Houston, Galveston, or over toward Beaumont, Port Arthur, and Lake Charles. Well, what if your hurricane response plan has a significant action that needs to take place within 84 hours of potential arrival time, or the forecast arrival time of those tropical storm force winds, where you're going to be left not taking any action? As it wasn't until about 60 hours before eventual impact that the forecast was for tropical storm force winds in the Lake Charles area. Well, Ike, of course, did hit the upper Texas coast, but what can we use as a tool if the storm is not originally forecast to put tropical storm force winds into your area? We can use something that we developed at Impact Weather called the worst case scenario arrival time. What we'll do is we'll assume that, well, your location's on the upper Texas coast. The storm's not forecast to initially hit your location, but what if it changes directions, moves more directly toward your location, and arrives a little bit earlier than forecast? Remember, that's problem number 3, the not accounting for speed of movement. Well, we take care of that with this worst case scenario tool. Now, the problem with that, as we saw with problem number 4, is that even though a hurricane might be within a certain time period or distance of hitting your location, it doesn't mean it will according to the forecast. Let's take a look at another tool that we can use in conjunction with the worst case arrival time. That's the probability of wind impact. You've seen these probabilities before. What we can do is we can calculate the probability of a certain wind field impacting your location, either on either side of the track or way out in advance of the forecast track. And we can incorporate this probability along with that worst case arrival time and use that as objective guidance in your hurricane response plan. But the problem is what values to use for that probability of wind impact. In this example, what we have on the bottom scale is the worst case arrival time, the number of hours remaining before potential impact, from 132 hours all the way down to 0 hours impact. On the vertical scale is the probability of wind impact, and in this example, we're going to use the 58-mile-per-hour winds. I don't have time to explain why we're using that particular wind field, but that's the wind field we're going to be using for this example. We looked at a number of storms in the past, from storms that eventually moved toward a location, eventually hit that location, and other storms that were moving generally toward a location, but 2 or 3 or 4 days before landfall, they eventually turned away from that location because we wanted to see what range of probabilities existed in both cases. Take a look at the first case. The hurricane is initially heading generally toward your location, and it does hit your location. Well, as you'd expect, the probabilities start out rather low and get very high, of course, near 100% as the hurricane is approaching your location. But what about those hurricanes that were moving generally toward a location and veered away? What kind of a range would I expect there? Well, there you go. The green line represents that. And you can see within about 48 hours before impact, most of the storms veered away and those probabilities dropped off drastically. We can see that, though, in this part of the curve, the probabilities are almost the same. 3, 4, 5 days before impact, there's a very narrow probability range that exists here, and we can use that in your hurricane response plan for those timelines here. In fact, we've calculated what those probabilities might be all the way up until about 24 hours before potential impact. As you can see, as we get to about 24 hours before impact, there's a wide divergence there in the probabilities. We don't want to use the probability of wind impact then. We'll use the forecast arrival time because by that time, either the storm is heading toward you or it's turned away. So we can use these probabilities in this range down here as objective guidance, and I'll show you how we can do that. Typical hurricane response plan again, that trigger, that proximity trigger at the top here, 120 hours out, 100 or 96 hours out, etc. Let's see how we can modify that plan to incorporate objective guidance. That first proximity trigger, of course, becomes hurricane risk identifier set to positive. But the other triggers from 120 hours out on to 48 hours out, we replace those with the worst case scenario arrival time of the tropical storm force winds within a 120-hour period, and the probability of wind impact, in this case the 58-mile-per-hour winds, greater than or equal to 8%. That's the 8% we found from that previous graphic that I showed you. And that works all the way down through about 48 hours before potential impact. At 72 hours, for example, worst case scenario arrival time within 72 hours, probability of wind impact, 58-mile-per-hour winds at or greater than or equal to 20%. If we get down to 36 hours before potential impact, we don't use the probability of wind impact or the worst case scenario times. That's when we start using the forecast arrival time of the wind field. And eventually your hurricane plan looks something like this. And now you have objective guidance incorporated into your plan. There's no more guesswork, and you're going to be operating or activating your plan at the same time. Each time a hurricane threatens, you're not going to have any guesswork as to when to activate each phase of your hurricane response plan. And that's more likely going to save you money and time the next time a hurricane threatens your area. And that's a look at problem number 2. I'm Impact Weather Meteorologist Chris Hebert. Thanks for viewing.